We're now going to solve the equation sine of 3 theta equals -1. We're going to restrict that theta is an angle greater than or equal to 0, but less than 2 pi. First, we need to find all angles whose sine is -1. Well, the sine of 3 pi over 2 is -1, so we know that 3 theta needs to equal 3 pi over 2. But then we have to take into account the periodicity of the trigonometric functions because of the fact that every 2 pi radian, the sine of theta is also going to be -1. So we add and subtract 2 pi k, where k is an integer. Now, we don't really want to know 3 theta, but rather we want to know theta. So we're going to divide both sides of this expression by 3, and the result is that theta is equal to 3 pi over 2 divided by 3 yields pi over 2, then plus or minus 2 pi over 3 k, where again k is an integer. Now what we can do is start listing out possible values of theta for different values of k. For example, let's say that k is equal to 0. For k equal to 0, we get that theta is pi over 2. Pi over 2 is between 0 and 2 pi, so that is part of the solution set. What about for k equal 1? Well, for k equal 1, we get that theta is equal to pi over 2 plus 2 pi over 3. If you work that out, pi over 2 plus 2 pi over 3 is 7 pi over 6. 7 pi over 6 is within the interval, and therefore we know it's a solution. What about for k equal to 2? For k equal to 2, we get that theta is equal to pi over 2 plus 2 pi over 3 times 2. That's pi over 2 plus 4 pi over 3. Pi over 2 plus 4 pi over 3 is 11 pi over 6. 11 pi over 6 is within the interval. If I make k equal to 3, then I have pi over 2 plus 2 pi, which is clearly outside of the interval between 0 and 2 pi. So my solution set is pi over 2, comma, 7 pi over 6, comma, 11 pi over 6. How do we know how many solutions we should be looking for? Well, if you look at the expression sine of 3 theta, what we need to consider is the fact that the period of the graph of y equals the sine of 3 theta is going to be 2 pi over 3. So, on the interval from 0 to 2 pi, there are fully 3 oscillations in the graph of the function. So, the graph of the function is going to drop down and be equal to -1 exactly 3 times. Those 3 touches of the graph at y equals -1 correspond to the 3 solutions that we've identified.